right. And we have a big competition, and sometimes we beat that. But it was Razi, by the way, as a clinical physician, who says in his treatment of various diseases, he noticed that there were two different diseases that were not distinguished in the Greek tradition. One of them is measles, the other one is smallpox. So he tries to apologize for the Greek material, and he keeps saying that maybe they didn't know what to call it and all that, but at the very end, he had to write a treatise on how to treat any one of those diseases and the clinical observations that he has taken. And as a result, he produces a treatise on the distinction between measles and smallpox. But that's not the reason why I bring this slide to you. Again, I'm killing the second bird. First, he is rejecting the Greek tradition. He is telling us that the Greek tradition is faulty on this. It doesn't have a distinction between those two diseases. But now, look at the date of the publication. This is published here in London in the middle of the 18th century. I invite you, ladies and gentlemen, to tell me why a publisher in London in the middle of the 18th century thought that he would make money from publishing, and every publisher is always intending to make money. Don't believe it otherwise. Why would they publish the Latin translation and put the Arabic right next to it if they didn't think that the Arabic still had a market, even in the 18th century, that students of medicine ought to be able to double-check the original when they are reading the Latin writing. So, for those who still think that the Renaissance was capturing Greco-Latin antiquity, they need to reread this text. And for those who think that the translations ended with the 13th century, they also need to look at this one and give me an explanation. I would be very happy to go along with whatever explanation you have that makes sense. Then we come to those famous Arabic numerals. Those Arabic numerals, again, they are the poor things. They are sort of like nobody wants them. You call them Arabic numerals here in this part of the world, but when you go to the Muslim world, and the Arab world in particular, we call them Indian numerals because we know where they came from. But this is the kind of evidence that I am willing to bet my last dollar that it came from Arabic into the Latin West. Not only because the name was Arabic, but look at this evidence. You all know that Arabic is a language that reads from right to left. Huh? And when it comes to the numerals, this author is telling us that you can write these numerals 1, 2, 3, 4, 5, 6 up to 9, or you have an alternative form and write them 1, 2, 3, 4, 5 up to 9. When you finish those, you put a little 0, you add the 10, count all the 10s. When you finish with the 10s, you put 2 zeros and put a 1 here, count all the hundreds and so on. It's teaching a very elementary thing on how to treat those numerals. You all know, of course, that English goes from left to right, and this is one of the oldest treatises on craft of numbering, which is very nice to give a treatise. But then when you get to the numerals, they go listed from right to left in exactly the same form that they appear in the original manuscript. This kind of evidence is not for laughter. This kind of evidence, I say, tells me that cultures, when they borrow ideas, they don't immediately assimilate them. It takes time to adjust to them. As a matter of fact, we still have not adjusted to the sexagesimal system that we borrowed from the ancient Babylonians, and we still count every hour to be equal to 60 minutes, every minute equal to 60 seconds. Then we still have not been able to sort of get out of it and use a decimal system, which makes much, much more sense. And here, I think, in this country, you are beginning to move into the decimal system, but wait to see if the Americans will ever change their inches and their feet and stuff like that. But the second evidence also comes from a French manuscript. And the French manuscript, as we see here, it says it is a treatise on the algorithm. Algorithm has already gotten into the picture. And the French, whether we like them or not, they're still just like us. They also write from left to right. When they come to the numerals, look what this guy had to do. This is in 1275, the date of this manuscript. He jumps down one line, he writes 1, 2, 3, 4, jumps back and writes 5, 6, 7, 8, 9. He still had to put them from right to left. He couldn't get over the idea of the order. He thinks that those numerals, the order in which they appear on the page, makes some sense. It took about 200 years, by the 1475, to realize that you can write them from left to right, and it's okay. They still have the same meaning. We can play with them. Meaning the culture matured enough to play with these new concepts that they were playing. And you are laughing. I hope that you don't laugh too much, because you should be laughing at yourselves also when you arrange your checkbook at the end of every month. What do? You put the units, you put the tens to the left of it, the hundreds to the left, the thousands to the left. In other words, you ascend You arrange the ascending power of 10 from right to left in exactly the way they were in the original manuscripts. Any mathematician here in the audience could tell you, I can arrange the powers of 10 to go from left to right in the flow of the language, and I can still solve the same problem and end up with 7,113. Why do we preserve that? Because we assimilated it and it becomes part of our experience, and we don't even stop to think about it, but we laugh at those medieval poor guys who were trying to be stuck with the same thing. Now, when it comes to the names of the stars, every single, and this map, by the way, comes from the National Geographic from 1970. It's not a medieval map at all. I invite you to the modern map, and every single name that is circled in red in this map is a transparently Arabic name. Now, why does the National Geographic has to do that? Why did the European civilization have to pick those Arabic names? It doesn't mean that the Greeks did not know about the stars. It did not mean that the Babylonians did not know about the stars. It only means that the ancient Arabian tribes, before the translations of Greek star names into Arabic, they had already developed single names for single stars. And hence, for the brevity of the reference, what has survived from the Renaissance time, and the earliest to do that was Peter Appianus, by the way, the earliest to collect those star names from the ancient Bedouin names, preserve them in the Renaissance until they reach the National Geographic, because they have these single name stars, and hence we can attach them first to astrolabes, then to tables, then to planets, and so on. Then we go into something a little bit more serious. Observational astronomy, or any science for that matter, that requires direct observations, has in its very nature a little approximated value that instruments cannot tell it with absolute certainty. We always measure with a little approximation. All measurements are made by all instruments with a little approximation. So when you take a measurement that was made in ancient Greece in 2nd century AD, and you double check that measurement 700-800 years later, whatever mistake and approximations you had in the original begins to be apparent later on. And one of those measurements is the measurement for the inclination of the axis of the Earth. This is what we still teach to our elementary science students, to explain to them why the seasons change from summer to fall to winter to spring. We tell them because the Earth's axis is slanted by 23 degrees and a half. I have you know, 23 degrees and a half is not the Greek value, nor is it the Indian value, which are the two main sources from which Islamic civilization drew any science. The Greek value is 23 degrees and 51. 23 degrees, 51 and 20 seconds. And the Indian value is 24 degrees. Both of them are a little bit too much, like about half a degree too much. And again, I have a standard joke on this one, very nice. If you think that a little value, like a half a degree, is not worthy of attention, I tell you, we are playing in a field that invented the term astronomical numbers. Astronomical numbers are very, very large. So if you give me just half a penny, and you allow me to multiply it by 10 to the power 8 by an astronomical value, I will become richer than Bill Gates. So a little half a thing is very, very serious when you multiply it by very big numbers. And also the proof that the observers at Baghdad between the years 800 and 835, who freshly observed this inclination, the proof that their observations were accurate and they were good enough to stand the test of time is that we still use that value up till now in all our textbooks, in our schools, and so on and so forth. So we should be grateful that those astronomers were doing that. But again, now that I have the opportunity,